Good morning. How's everyone doing? Good. So if you the exams, a PDF of your answer sheet is posted in Canvas gradebook. I believe you just have to go into the gradebook and click on the score and it will open it up. It will show you what you got right, what you got wrong, and what you got partial credit on. I guess it's in a purple color. So if you got half the points. The exams overall went really fairly well. The total was based on 28 questions correct because there was 9 people who got exactly 28. There were 2 people who got a 29 and one person got a 30. Um, but I kind of go, where's the biggest cutoff? So would do that. So your scores are based out of 208, 28 questions. Um, so some of you got either, if you had 28 right, you got 100%, and if whatever you got below that. What I do is you'll be able to pull those up. They don't have the questions because they do reuse those questions. Sometimes they change the order and stuff, but they reuse them. So I have them here. You'll be able to do what I call test corrections. Um, and for test corrections, you can't just give me the right answer because you could probably find the right answer here somewhere. What I want you to do is show me 2 things. Uh, I guess first, how to correctly get to that answer, and then an explanation. Now, some of these might, whatever it is, but you can get half the points back for anything that you missed. So everybody can get to where a passing grade. If I also have another version of the test that's online. Um, so if you just wanted to do a complete retake later on, we could make that happen with sort of a different version of the test, the online version through the Moore system. I think it's a little bit harder because it's not the multiple choice. Uh, and generally, the option to just rework any missed questions is the best option. We'll provide you with um, a good score. Okay. Uh, what we'll do is I'll make those available whenever we have work sessions. So after today's lecture, there'll be that time to work on it. Or when you come Wednesday, which is a work day, you could work on it then. Okay. But the one thing I don't want you to do is to get behind on the current work to try to make up for past work. So sometimes you always feel like you're playing catch up. So, but again, that's up to you. The other thing I will do is I'll also drop one of the homework and quizzes scores. So one basically a chapter. So if it was previously you didn't do one of the chapters, you could that could be the one that you drop. I'll drop the lowest. Uh, if you've done everything already, you could take a look and say, hey, I'm going to be busy at this time and I'm not going to do this one. The one problem though is if you don't do the work for one of the next chapters, chapter 7 through 12, those are all going to be on the final exam. Now you could say, well, that's only 5 questions, I'll be fine with but that's up to you. But I will drop the lowest homework score, so your grade will be based off of 11 homeworks. Now if you do them all, that means one of them's extra credit, so that it kind of plays both ways. If you do them all, you get a bonus. If you don't do one of them, you don't get hurt. Okay, does that make sense? uh, Test corrections are there. uh, we generally can't do test corrections at the end because there's no more time left after that. But I'll look into seeing how. I think what I can do is we'd have the test, because on finals week we still have 2 days of meeting. We could have the final, which is the same size. It's just and over this chapter 7 through 12. We could do that on the Monday, and then anyone who wanted to do test corrections could come back on Wednesday. So we'll try to make that happen. Um, and anyone who maybe needed more time to study could just take it Wednesday. But if you take it Wednesday, you won't have the opportunity to do test corrections. We'll just put it that way. Does that sound reasonable? Okay, we'll do it that way. Try to make the best options for uh, all of us all. So the other option I wanted to share with you today is this project, the Math of Blank. Okay, this is an optional project. It replaces, I don't know, about 20% of the grade. So what that does is if you didn't do so well on the exam, you could basically have 20% of that score. And it's 30%, so it's only going to affect 10%. This will affect 20%. So the project, let me click on this, and these are older instructions, but they're just sort of a guideline. What I want the project to be is how math is involved in something that you're involved in. Okay, it could be a hobby, could be your career path. It could involve some of the math we've already done or that we're going to do, but it doesn't have to. And I'm going to show you some examples of things that have been done in the past by other students. What I want from you is to address two things. I want you to write up a summary of how math is used in that activity. Let's just take the math of baseball, let's say, and you're going to focus on one aspect of what's the mathematics of a home run ball. And what you'll see is you can look it up. When the ball hits, it's going to be a parabola. A quadratic equation is what they end up being. And so you can, and again, you could just look up things on YouTube or wherever, TikTok, or they got a lot of good math stuff in there, the math of baseball, and they'll get something. Or maybe you're going to go on how fast the person has to run to steal second base or something, whatever that, any kind of thing that involves numbers. Okay. You're going to write up a summary, 1.5 to 2 pages, double spaced. So that's really not that much, but focus on a particular aspect of mathematics in a particular field. You will also do a presentation. You can record that presentation, send the video to me. Okay. You can do the presentation just individually to me. So I've had students just kind of talk me through what they're doing. And sometimes as they talk me through what they've researched, that is sufficient. Okay, thank you. So we'll work it that way. If you want, I've had students who were willing to present it to the class, maybe like on a work day or something, because a lot of times there's some really nice projects that have come out that, and again, I've had students do, well, we'll go through the list, but that's the two aspects. If you do those two things, you'll earn all the points. And it's enough to, again, replace about 20% of an exam score or any score. And basically, if I've had students, even if they didn't do well on the exams, if they do this project, finish all the homework, you're still in the B to A category, okay, depending upon how you did. But okay, so there's some details here. Let me go through a few of the examples, and you can look at them in more detail. There, some of them by the end of class. Yeah. So you might want to get it in earlier or something, but we'll do it throughout the time period. It's something, it's sort of like an extra project, and we'll talk about it whenever you want to do it. Sure, it could be an honors project as well. You just have to make sure if you could step it up as whatever honors requires. They might have some additional, like I think they have like a 5-page paper or something, whatever they need. You step it up to that, it'll count as both. Yeah, it's a great option for that. Where are we? Okay, so here they are. So there's a bunch you can do this math in Islam. So how when you're counting beads and such. So there's counting, math in nature, and these are videos, so you could watch those. Math of blackjack, how to win. So this is on card counting. So this is a system. I've tried it myself. I just can't. Anyway. I've read it. I've played it, but I haven't gone to the casino and tried it because I get bored too quickly and I can't follow the system. I know I can't. So, but some people have done well. And I had a student who actually worked for the casino, and they trained him how to count cards. And the reason they did that is so that he could watch others, and he spots how they're betting and says that person's probably counting cards. Now, it's not illegal, but when they spot you doing that, they will ask you not to come back and they will throw you out. So that's what his job was for, is saying, hey, that person's probably counting cards. Tap him on the shoulder. It's time for you to leave. But because It doesn't give it just gives an advantage if you can do that. Again, it's not illegal, but it's also the casino's right to refuse service to anybody they want. Anyway, that was kind of interesting. Um, this is one of my favorites because I used to have a Jeep. So this guy, I'll show you just briefly, put a whole PowerPoint together. He did the geometry of. Maybe I'm gonna have to download it. It's internet's kind of slow. Let's see if we get okay. So he did a lot more to his Jeep than I ever did to mine. So he raised it. He really takes it off road, as you can kind of see here. See if I can make it bigger. So, and again, you could go through there, but here's his mathematics. You know, all the numbers involved, bigger tires, how he uh, did the lift, how he got all the angles and stuff. Um, let's see if it comes up here. He shows you here the geometry, how everything has to work just right, and then the weekend before he was going to give his demonstration. I mean, this is pretty extreme stuff, right? I mean, I I go out on gravel road is about as bad as I got, you know. So he did this stuff. Uh, he shows that there's tools on angles and stuff, and how you get the correct drive shaft angles. Everything's going to be good. But the weekend he went out, one of his buddies had the incorrect drive shaft angles, put too much stress, and broke his drive shaft. So they had to get him out. So, and here he is. But notice how his Jeep can really handle all the different terrains. That's the mathematics of Jeeping. So it was just cool, you know. Getting someone, I've had someone do BMX bikes, you know, and riding and angles and speeds. But again, the goal of this is for you to find out how math is involved in something that you're interested in. Patterns. There's all sorts of types of math. And that was one of the aspects of this class that I really liked that had kind of gone to the wayside, is that there was like an optional section we would always do. And we could do the cultural math. We could do a lot of different things. So this brings that in, allows you to replace 20% of the course grade into something that you're interested in. It really shouldn't take too long, because hopefully you choose something you're already an expert in, like he was. You know, he just took his Jeep and this is all the things he already did to it. He just put it together, took a few pictures, and that's good. He had a nice little presentation, but he could share something. I've had a pilot do the math of dew point, because I guess that's really important for a pilot, knowing what the dew point means and how high you can fly or low, and where the cloud cover is going to start, all that kind of stuff. He explained it great, because and again, it was something he already knew. So I'm sure there's something you already know about some aspect of your life that you could, again, share with us. And again, you could do it. I've had, take a cell phone video, upload it, and that's your presentation. Or just talk to me. It doesn't have to be a big presentation type thing, but just the two goals we're having is that you can communicate mathematics verbally and in writing. So a brief summary of what the mathematics is, and that will get you those points. And again, you fit it in. You could do it early, you could do it later, have till the end of class, our final last day, to get those into me, and we'll talk about those. Any questions on the project, optional project? Okay. And if you're not sure what you could want to do, talk to me. I had some people, I have no idea what I would do. And I said, what do? You have a job? Yeah, I'm a waitress. Well, how do you know when you're getting a good tip? There's that math. I said, well, that's just adding and subtracting. Well, that's math. Okay. So there's a lot of things we do in our daily life. You don't have to, it's not like you're giving a lesson on how to do it. You're showing how math is used. Okay, so that's that. What we're going to do today, and so another thing is, for chapter 7 is sets and Venn diagrams. I'm going to click here. There's several documents that you can download. I printed off the worksheets that we're actually going to use. You can use the worksheet. If you complete the worksheet, we'll give some details as we go through it. We're going to work through part of this together once I get through that part of the presentation. you could use these worksheets in place of the homework and the quiz. Okay, so this is worth 30 points if you complete the parts I'm going to ask you to complete. And I don't know which we're going to complete because we're going to do some of it together. What we don't do is what you'll complete on your own or together working with someone. So you could use this, or you could do the online stuff as well, and same as you know. There's videos where I've used this and plus other things. So there are several videos on how to do Venn diagrams um, that are there, and there's a PowerPoint. So this is two things. It's kind of set understanding what sets are, how they're used, and Venn diagrams. It will do two things. It'll prepare you enough to actually do the online if you want, or certainly to work through this because we're going to do much of it as examples when we get to there instead of doing the quiz. Okay, so let's start off. I've already downloaded the presentation. Forget how a slideshow. Got so used to using Google Docs that I forgot how to use PowerPoint. Do it this way. Okay. So basic concepts of a set. What is a set? So we're going to go over just some terminology, so vocabulary, and then we'll use the worksheet to get into Venn diagrams. So this is from a different book that I've used before. We're just going to look at the set and operations in them. We've got some things to help us. We're going to do all this stuff. What is a set? If I had a tea set, what would I have? Cup and saucers that have the same pattern, right? But a cup and a saucer are different things, yet they have a similarity. They've got something that matches. And that's what a set is. It's got something that's similar about all the things in the set, but there also could be differences. I could do the set of all pickup trucks. And that would be, if you see a pickup truck, that's in the set. However, they could have different colors, right? And so we'll see how we can differentiate between things. So there's similarities and differences between something that's in a set. Venn diagrams is credited to John Venn. That was his last name. And basically, all he did, let's see. Oh, that's right. I got to get a different pin set here. This one. So Venn diagrams, what he did was he took circles, and if it was in the set, let's go with pickup trucks. Then it would be in the circle. If it's not in the circle, then what do we know about the thing that's not in the circle? It's not a pickup. We don't know what it is, but we know anything out here is not a pickup. Then, additionally, you could have overlapping circles. And this other circle has some other quality. We'll say these are blue vehicles. Blue vehicles. So, if something were here, what do we know about that? Pickup and it's blue. A blue pickup. If something is over here, what do we know? The blue, it could be a car, it could be anything but a pickup. It's not a pickup, but it could be some other kind of truck. But all we know is it's a blue vehicle. And then again, if something's out here now, what do we know about this? We know it's not a pickup. We know it's not blue. And we know it's not a vehicle. Well, we know it's not a blue vehicle at least, right? Not a pickup or a blue vehicle. Okay. So that's all of the circles are, is you're either in the club or out of the club. But it can get complicated because there's going to be overlaps. Um, and then there's also the stuff on the outside. Okay. And oftentimes we'll use a rectangle to represent everything. This is called the universal set. It's everything that we're talking about. Um, and we would call the rectangle the universal set. These circles designate smaller sets within the larger set. Okay, and we'll talk more formally about that. But that's all the method is. You're either in or you're out. And again, we're going to work through some examples together. Hopefully it becomes fairly clear what we're doing and the different uses for Venn diagrams. Forget what this one I have to erase. So this is kind of going to summarize what I summarized what we're going to go through in the next few slides. The universal set, and then set A is within the universe, but it's only the things in the circle. Okay, so we've kind of talked about that. Some of the ways we can write things, this is called set builder notation. And it's simply with these curly braces, we read this as X. This little bar is simply read as such that. Just kind of a weird construction, but it's a mathematical deal. That X is an element of the universal set, so it's in that rectangle, but it's not. Notice this scratched through the little e. So this little e means element or item or member. So X is in the universal set, but it's not in the set of A. And notice the only difference here is this little prime. This is read sort of not A. It's all the things that are not in A. So it's the things outside the circle of A, but in the universal set. Okay. But don't let again, a lot of things with math is they get this sort of shorthand notation that can really throw you off because you got these symbols, you don't know what they mean, and you think they're real complicated things, and they really aren't. And that's the thing of this bar, is just it throws a lot of students off, but it's a way of saying such that X. It could be left off. We could just say, hey, this is a set of things where X is an element of the universe, but it's not an element of A. This is just formalizing it. So you'll see it. Okay, you'll see it. Questions so far? Okay. We could talk about subsets. Okay, a subset is sort of part of a bigger set, and we could represent here where A, this is read A is a subset of B. So we could visualize it that A is contained in B. Now, it is possible this little underline here comes from the equal sign, kind of like less than or equal to. This is a subset, but A could actually be equal to B with this particular symbol. There's another symbol, which we're going to see in a moment, but I like to put them both on the same page. If I write this subset symbol, this means they can't be equal. This is actually for what they call a proper subset. Okay. So it means they're not equal. And it's only proper because if they're equal, they're really the same set with different names, right? Like you can call me Mike or you can call me Michael. I have family members, I go by both names, plus probably a few others. But So that's all it's saying, is that it's not really a subset if they're the same set, in a sense. But yet they are. Each set is a subset of its own. Okay, so you can have them equal, but then you have to use this special symbol over here. This is if A or B could be equal. Not have to be, but they could be. But over here, if we use this one, they're not equal. Okay. And we're going to, and again, when we go through, we'll be using these, and that's when they'll really, you don't have to memorize them, but just be able to recognize what they're saying. So we'll go through some examples. And if you didn't notice, but that last link in the homework part, I've actually given you all the answers, so you can pull them up. But my goal is to get you to try some of these, check your answers, and see why you were right, or maybe why you might have been wrong. What did you leave off? Okay, so it's just kind of, again, we're not trying to make you Venn diagram experts. We're just getting you some experience with using Venn diagrams. Okay, so ABC, is that which one of the symbols would we use with ACD? Are these subsets of each? And again, it's from the left to the right. Is ABC a subset of ACD? Okay, ABC is missing the D, so it can't be. It's got to have at least everything from the other one. It's got the A and the C, but it's got something different that's not in here. So these are not this is not a sub. This first one is not a subset. Oops. Well, it told us. But the last one is 1, 2, 3, 4, and 1, 2, 3, 4. These are subsets of each other, and actually they are equal to each other as well. So we can use this symbol. Okay, but again, the one on the left has to have all the elements, all the same things that are in the one on the right. They could have less. So one other example of a proper subset, if we had 1, 2, 3, but not the 4, we could say that's going to be a proper subset of 1, 2, 3, 4, right? So we could use this symbol. But that's a proper subset because it's not equal to. 1, 2, 3 is missing the 4, but it's got the 1, 2, 3. It is contained. Basically, think of this set is contained over here. Yeah. Well, the left side is the right side is the full set on these always. The left side is supposed to be the one that has either less than or equal to, but it has to have everything. This is not because it doesn't have everything in here and it's got some extra that isn't in there. Okay. So thinking of it, if we go back here, visually, set A, notice A has to be sort of contained within B. Okay. And again, we'll go through some examples and sort of non-examples as we work through it. This is just giving you enough to kind of get you going. And this is what I was telling you. If they could be equal, we can use this symbol. If they are equal, actually they are subsets of each other. Because again, they're just really the same thing with different names. I call it A, I call it B, but it's really the same thing. Okay. And then this is just the idea of a proper subset. They can't be equal. So A is only going to be a subset of B. A is somehow smaller. It doesn't have all the sets. Everything in A is also in B, but B has something more. And okay, and so here, ABC, is it a subset of ABCD? Can we use what's the most restrictive? Are they equal? No, they're not equal, but certainly everything in this side over here, ABC, is over here, so they are subsets. 1, 2, 3, 4, we talked about this one already. Since they're equal, we can only use the one symbol. We can't use the restrictive one. A, we could actually use either one of them. We could use both. Subset that could be equal or just the proper subset. So far, so good. Okay. And if you're interested in this, if this stuff is kind of, it's not really interesting to me, I'll tell you that off the bat. But if you're interested, there's a class we have called Philosophy 103. It's logic. Um, and I've had students who didn't really like math, but they loved philosophy, or they loved logic. I don't really like logic. It doesn't seem logical to me sometimes. But it's kind of gets into that frame of mind. And I've had students who've done really good, and they'll come and ask me questions. I said, I'm not into logic. I don't know if I can help you as much. I can help a little bit because I'm an amateur, and so that's all we have for this. So now what we're going to do is we're going to get into the. See, I'm going to pull it up here. I think this one. Okay. So I'm going to. Would anybody like to help me out by passing these? Make sure everyone has one of those, however you want to do it. You want to just toss them and let them catch it, or no. Or pass it on. Take one and pass it around. So we're going to do this. And again, if you're maybe watching this from the recording and you don't have the printed versions, they are in Canvas, so you can download them. You can even do this electronically like I'm going to do if you want to. Where I'm going to start is actually on the last page. So we're going to do a couple of these, but, oh wait, I've got to open up a different document. Oh, 2 example sets. So we're going to go with this as examples. And this is, I gave it to you as the last page because then it's easier. Maybe you don't have to turn that part in. If you want to tear it off, it might be helpful to take a look at the examples while we do the other stuff. Okay, so this is how we would shade Venn diagrams based on the logic. So this is the logic statement. And we'll do some of these together again on the front page. But the last page, I just want to. So this is, if I was just given the set A, I would shade everything in A, and we're going to have you do some of these with 3 sets, and we'll look at those examples. These are just kind of like your a study guide. If I wanted B, then I would shade side B. Now this one we could list it both ways, either A with C, which means A complement, or in the other presentation, it was A prime, or not A. So everything that's not an A gets shaded. A is not shaded, because that's what this symbol means. Okay, and same thing with B. The complement of B is the same thing as B prime. So 2 different ways to list it. So again, everything not in B. We're going to introduce this symbol here because it wasn't done before, but A union B. So the symbol U, with the U, you could do it that way too, means union. It also means or. You'll see this, and this stuff that we're doing, well, again, you could skip it, but we're going to use this also, this logic, when we get into probability, where our chapter 8 and chapter 9. Okay, chapter 8 and chapter 9. So this is the or, but in logic, it's the inclusive or. Okay, so I'm going to mark that in. This is one of the hardest things of logic, is they use the words in a different way than we use it in everyday English. It's an inclusive or. So if I ask if you want chocolate or vanilla, usually you're thinking I can have one or the other. But when we use or this way, it means chocolate or vanilla, or the swirl version, which you could have them together, right? So this is either or. And then And again, you can do this multiple ways. Here's the intersection or the union, the complement of the union. So that's everything that's not in the union. So we can see how we can get it more complicated. The other main one we have is this symbol here, which is an upside down U, which means the intersection. So when we have this symbol, that means intersection. And the word that gets used with this is the word and, but it's an exclusive and. So do you want chocolate and vanilla? Sometimes, oh, I could have chocolate or I could have vanilla, or I could have, we use it, typically we use and in an inclusive manner. In logic, it's exclusive. It has to be both. You have to be both in club A and club B. That's where you're in the intersection, the middle of the road, okay? So this is an exclusive. But I always get them wrong because I think in terms of how they're used daily, and is more inclusive, right? But in set theory, and is exclusive. So think of it, it's the middle of the street. You know, it's where your mother told you don't go play, right? You live on this, because I grew up in the street. So, but we always loved to play in the intersection because that was the open place that you could do stuff in, right? But that's also where two streets crossed each other. You were on two streets at the same time, and you had to watch for traffic. But hey, we did it. I guess it wasn't like a real busy street, but when cars came, yes, they went right through our play field. Um, so we got out of their way. Okay, that's the only smart thing to do. So intersection, right? So it's both A and B. Um, and then we can also, again, here's some others that might be helpful. If you do an intersection, but you do the complement, it's everything but that intersection. So you can see how that C, that complement, or we could write it as A intersect B and use the prime. It's everything not in that intersection. Okay, so you'll have access to these, and I don't clear this out. We won't go through all of these, but different ways. We're going to get to some more complicated ones when we do the 3 circles. We'll do a few of them together, and then you'll give it a try. But again, you'll have an answer key that you can pull up and you can check. And my goal with you is, yeah, you could just pull it up and copy it if you wanted, but how much do you really learn from that? Maybe a little. So I'm not worried about that. I want you to use it in a way that will help you out. Okay, so here's some statements that you could come back to as we go through our worksheet. Okay, ready to start into the worksheet? Okay, so this is what you have. We'll start on this first page. And we'll do, again, you could just look at them and copy them, but let's see if we can kind of go through these and figure out. So if we want A union B, what would we shade here? A, everything inside circle A. And if you want, you could double, and everything inside circle B, so you can kind of see there's this overlap. So you get the intersection and everything else as well, right? The intersection is a subset of A union B, right? So it's everything. Well, what about A intersect B? Just the middle part. So this crosshatch area, that's all that's included. So you just kind of, and again, you could take this right off the sort of that answer key. Now this one is one, some books use this, our book doesn't, I haven't seen it, but A minus B is a concept that it's everything in A except, so this minus is subtracting off, think of this as subtract off B. So it's a symbol that can be used. It would be everything in A, but not the part that's B. So it's like it got a bite. Cookie Monster took a bite. Does that make sense? Okay, so we could use this one as well. And again, that's the thing, is you see with different systems of logic kind of have their own special symbols. This can be done with intersections and unions, but it's a little bit more and stuff, but it's a little more complicated. Okay, let's get rid of those. Now we're going to talk about sort of cardinality, or how many things are in a set. So in this case, we're going to talk about the set, that this 11 is not an element itself. It's saying that in this region there are 11 elements. Okay, so there's 11 things in there. In this little region, there's 5 things. This little region, there's 3 things, and so forth. So if we want to figure out how many elements are in A, how do we count that? We add them all together. So it's everything inside this circle. And notice this 5 is inside A, but it's also inside B and such. But all we want to know is what's inside A. So we're going to take, let's go here. We're going to take 11 plus 5 plus 3. But you've got a good idea. If you're thinking subtraction, there's going to be times when we are actually going to subtract off things as well. So this one, again, we'll do this one together, is 16 plus 3 is 19 items. So there's 19 items. You may see this if you do the homework. It would be the number in A, and we would say that's 19. So this is sort of some notation. And I try to, this is the way I do things, is I try to teach things as we're using them, because they seem to make more sense. You go off and just define everything. You need a little bit of background, but I think that's enough. So far, so good. So how many elements are in A union B union C? How would we do that? Everything inside one of these circles. So it's, yes, exactly. So this is our boundary. Now, if there was something out here, we wouldn't add it, right? But there isn't anything outside there, but it would be everything here. So yeah, 11 plus 5 plus 3. Now, they only get added once though, right? So even though this 5 is in A and B, it doesn't mean that there's 10 things there. There's still only 5. So we count everything once, plus the 7, plus the 1, plus the 14. Okay, so you could do that. How many elements are in A intersect B intersect C? So when we look at the intersection, where's that? A intersect B intersect. So it's the intersection of all 3. Would the 1 be an intersection? Would just be the 3. The 5 is an intersection of A and B, but it's not in C. So it would get left out then. So yeah, you could do this sort of in order. A intersect B would be both 5 and 3. But then when you intersect it with C, you lose the 5. Only 3 is in that 3-way intersection, right? 3 streets coming together. So these got, and there's nothing there. So just 3. And then we could talk about A union C. And again, it's almost like B doesn't exist. A union C is going to be everything in A and everything in B, or sorry, everything in A and everything in C. Okay. So 11 plus 5 plus 3 plus 1 plus 14. So far, doing good? Okay. Clear off this stuff. Where were we? So how many elements in B intersect C? Here's B, here's C. This is their intersection, right? We can basically ignore, just, you have to kind of ignore A. It's 3 plus 1. And then this one uses B minus C. And this is a slightly different concept, right? It's everything in B, but it's sort of like what was in C as well gets deleted. It gets bitten off. It's subtracted off. Whatever's in C that was in B gets subtracted off. So it's just this region here up to here without C. So it's going to be 5 plus 7. Okay, so see how these symbols tell us what regions of the Venn diagram we're talking about. And when we have 3 sets, we have 1, 2, 3 main regions that are individual. We also have this region out here, which is in none of them. There's 4. And then there's this region 5, 6, 7, and then this middle. There's 8 different places we could put things, and it tells us something different about what that thing is, right? The one in the middle has all characteristics of whatever A, B, and C are. Okay, it's got that similarity. And we're gonna do the example together, and then you're gonna do 2 on your own, okay, as your homework. Okay, so now let's get into the shading. And what I'm going to do is we'll do 2 or 3 of these together, and then I'll let you, as your homework, to finish it up, complete 3 more, 1 from each row. Oh wait, not 3 rows are this way. So 1, 2, 3, 4. There's 4 rows, so do 4 of them. Okay, but I'll ask you, and again, you can probably choose one that looks more difficult. From 1 through 12, which one would you like to do together? Maybe we'll do 2 of them together. Number 5. Okay. And what I'll tell you is you'll need a sort of a pen and maybe something, or a pencil, that's something that you can erase, because we're going to go through this. So what you want to do when you go to shade these is you want to start within the parentheses, so it's order of operation things. So this is not A intersect not B. So what would that be? So first, I guess first we have to label this, right? We'll call this one. And you might label it different than mine, so yours might look different than mine depending upon how you label it. But I'll kind of go A, B, C this way. So if you do it, then we'll all look the same, but it's not necessary. What's not an A, and I guess what's missing here, right, is the rectangles, because that gives us the ability to go there. Not A intersect not B. Now, this is a little complicated. So whatever's not in A, not in B, the intersection. So not A would be everything outside of A. And again, you may have to use sort of, so not A would be everything here. Sometimes you might want to do kind of on the scratch paper this sort of work, because you might need to erase some of this. Not B, I'm going to shade the other way with maybe a different color. Not B would be everything outside B. And the intersection would be where we have both shadings. And so then that's where in the homework, I believe this, no, it's a different system I've got. You kind of have to come back and say, okay, A only has one of these, so I'm gonna, it doesn't, this eraser thing doesn't work real well. I kind of need to erase those parts and then come back and, oops. So I took out this part, so it would just be this stuff that's not in A. And of course you'd erase the stuff that's in B. Oops. Still have this thing out here. So it's everything outside. So everything that's not in there. And then the last thing says intersecting with C. So it would just, when we're done, we lose all this stuff on the outside. It would just be this part here. Then I could come back and erase. None of that stuff. And for this one, doing these ones that are a little bit more complicated, you might want to watch the video. And in the video, I make two different ones. So I go from one to the next, working inside. And this part is not in the homework because they couldn't get a real good tool for the shading. But again, if you do this, that replaces the homework. So you can kind of see how you're going to, with each of these, you're going to need to work inside the parentheses. And then there's one last thing to add on, right? So we do A union B. I'll do one more, a little easier one. A union B, here's A, here's B. It's everything in A and everything in B. There's A and B. And then we add on C, everything, we union it with C, everything that's also in C. Okay, we can get, it's basically all the circles. So you'll see unions are actually easier because you're adding things on, right? Intersections are a little bit harder because you may start excluding things with an intersection. So when you do an intersection after an intersection, you may have to do some erasing. Okay. And the knots, look at them, there's some, those are a little bit more complicated. But again, you have the answers to these. If we come back here, link to Venn diagram worksheet solutions. Let's see, I'll just pull them up here. It's been a while, so I've gone through and done a shading, so you can sort of double check. We did these, and we did number 5. Here it is. This is what the result is. So you can do a check, but again, I encourage you to kind of look at them on your own. I think I got rid of this one. Let's see, is it there or not? I think I got rid of it. So you don't have it, you don't have to worry. No, here it is. So then doing a description of these, what does this shading mean? Well, that looks like A union B. Again, you could check these. It's in the study, it's in the solution guide. So if you've got this view, what does this represent? Okay, in symbols. And then what we'll do is, so do a few of these together. Again, you can check. And if you want to go back and forth, that's fine. It's just getting you a way of sort of training yourself. But here's kind of where the use of a Venn diagram is most beneficial. And there's one in the homework like this that's like this. Basically, we have 3 groups. And so first of all, we've got 3 different sets in each of these. So we can do one that's a survey of students in either an English, political science, or history class. We could do one that does the preferences on people in a wine tasting, 3 different types of wine. And there's this one that has peaches, and you have either early peaches, late peaches, or extra late peaches being shipped out. And then we have some information. And what we need to do is we need to set up the Venn diagram with how many are in each of the regions. And then we'll be able to answer some questions. We will do one of these together, and then your assignment, if you choose to do this one, is to do the other 2, whichever ones we don't do, on your own. There's not a solution for this, but 2 of them for you to give a try. Does anyone have a preference which ones they would like to take a look at? 1, 2, or 3? 3? 3 okay? We'll do 3. Okay. So let's do this. Make it larger. One more time. Okay. So I'm going to fill in these, and I'm going to show you sort of the way that a student helped me. I'll be honest with you, when I was learning these, I did these backwards. Uh, when you fill in a Venn diagram, where you want to start is from the center and work out. There'll be less erasing that you'll need to do. Okay, so what we've got is so they're toward the middle of harvesting season. Peaches for canning come in 3 types. So we have either the early peaches, the late peaches, or the extra lates. So that's what our 3 sets are going to be. I'll do it in black. So we have to label one. We'll just label this maybe as the E's for earlies. The lates will be L, and the extra lates will do that EL. So those are our 3 sets. And notice there are some overlaps for each of these sets. What we want to do is this says, depending upon the expected date of ripening. During a certain week, the following data were recorded at a small fruit receiving station. So and what you'll see is there's trucks. 34 trucks went out carrying only early peaches. 61 had late peaches, 50 had extra late peaches. So the natural thing is to start saying, oh, there's 34 early peaches, so I would put that here. But no, what you want to do is you want to find the center ring first. So you keep reading and you see that 6 trucks had all 3. Okay, where does that go? In the middle. Here's this intersection of all 3. There were 6 trucks that had earlies, lates, and extra lates on its docket. The next thing you want to do is you want to go to the ones that have 2, only 2, not all 3. And so earlies and lates, earlies and extra lates. So, well, actually, the other thing, remember, there's this thing out here. Depends on the information they gave you. 9 had only figs, no peaches at all. Where would those go? On the outside. They don't always give you that. Sometimes you have to fill out the circle before you get there, but we know that there's 9 here, trucks that had nothing. Okay. And then what we want to do is we want to backtrack. 8 had earlies and extra lates. Earlies and extra lates. Where does that go? It's right here. But do I put an 8 here? Thing is, these 8, I've already got this 6 is also earlies and extra lates, right? It's also got these, but earlies and extra. So I've counted 6 of them. So I have to take the 8 minus 6. There's 2 that are just in this place. So 2 of the trucks had only earlies and extra lates. These 6 had earlies and extra lates. So there's our total of 8. So that's the key. If you do it this way, it's a lot harder to make the mistake, whether you're working in and sort. So you're going to be subtracting off rather than adding on. Okay, so we took care of that one. Here's another one. This truck, the 30 trucks had lates and extra lates. So 30 lates and extra lates, which would be this football shape size. Notice we've already counted 6 of those 30. So we want to, for this one, we want to take 30 minus the 6, 24. That's what goes in this little part of the football. Is that making sense so far? Okay. Then we keep backtracking. 25 had earlies and lates, so that's this intersection over here between the E and the L. If there was 25, but we've already counted 6 of those, so we need to take 25 minus 6, and we get 19 in this little region here. Now we're ready to take on the ones that had only one type. So we had 50 that had extra lates, but we don't put the number 50 with the extra lates because we've already counted 24 plus 6, which is 30, plus 2. We've already counted 32 of them in this intersection area, so we need to take 50 minus 32. And that gives us 18, which we put down here. And so in the early extra lates, not the early lates, you can't be early and late at the same time, extra lates, if we added these together, we should get the 50. Okay. 61 had late peaches, so that's over here. But again, we don't put 61 over here. We have to see that there's 19, 6, and 24. We have to add those together and then subtract them off. That's 30, 49. So this one, we're going to have 61 minus the 49, which gives us 12, I think. 61 minus 49 should be 12. And then finally, we had 34 trucks went out carrying early peaches. So 34 of those. And how many have we already counted? We've got 19 plus 8 is 27. So that gives us 3 plus 4 is 7 are out here. And we've taken care of 9 had only figs. Now we can answer all these questions, A, B, C, D. And you're going to see there we don't have to do any more calculating for the most part. How many trucks had only late variety peaches? Only lates, right there. We see it, it's in that means that only lates, they were not in intersection. Got our answer. How many had only extra lates? Extra lates, right there. We've already done the calculation. Notice you might be able to go through this without doing the Venn diagram, but I bet you it's a lot harder and it's more error prone. Once you do the Venn diagram, it's a lot easier to figure out how to do it. How many had only one variety of peaches? Well, that's 12 plus 18 plus 7. So we still have to do the calculation, but it would have certainly been hard to calculate from all this information. Only one variety. So it's the 12 plus the 18, which is 37. 37 of the trucks had only one type. And then how many trucks in all went out during the week? We add everything together. Okay, even these 9 out here that had figs, because those were trucks, right? So we would add all of those together. Okay, so still a calculation, but if you try to add all of these together, remember some of these, you're going to count them twice. Some of these trucks had both, and the only way to get an accurate count is to add all the Venn diagram together. Okay, and I'll leave that for you to do. The key part is how to make this Venn diagram. Now for your homework, if you could turn this in to me, I mean, all you have to do is complete it. The first 2 pages, you have the answer key, so you can check them yourself, and I want you to do that. I'm just going to basically, you hand it in to me, I'm going to base off a completion, and then do 2 of these so that you now have the question with the wine. Take that off. And again, do the same thing, make the Venn diagram. You'll be able to answer these questions fairly easily. And do the one with the classrooms, which class they're in. So these 2, 1 and 2. Okay. Do those, do the first 2 pages, get that in, you've got 15 points. Doesn't have to, you could work on it Wednesday if you wanted, or next week, or whenever you have it done. And maybe you're going to set it aside and do it later. I'll take it because I'm not going to really grade it because I've given you the answers. You can grade it yourself, except for these last 2. If you have questions, we can answer them, but it's going to be based on completion. Okay, so this unit, you could do this, or you could just do it online, and I'll see as long as you get to 70%, I'll give you the 15 points for the quiz, 15 points for the homework, if you want to keep going that route. But I think this one's a little easier. And then remember, one chapter, one full chapter, 30 points gets dropped from the grade or counted as extra credit. So that's a way. The past ones are still open, so if you wanted to work on those, you could still do them. If you've got them all done, that's great. You've got the next 6 that, again, you could choose one to not do if you wanted to and be okay, or do it as extra credit. And the way I've got the points, it's off of, everything's off of a total of 1,000 points. So it's kind of additive. So 30 points is 3% of your grade. So again, it's either 3% extra credit or 3% not taken off for not having to worry about that. Any questions? Okay. So Wednesday is a work day. Again, we can work through some of this if you want. It's up to you, whatever you want to work on. Work on past things. I'll have exams, copies of the exams. I have them now if you want. If you want to do test corrections. What I ask you to do is on test corrections is just put on a blank piece of paper. It doesn't have to be specially formatted. List which questions you're working on. And again, just give me an explanation of how you got to the right answer, how you understand the right answer now, and then maybe if you can spot why you chose the wrong answer, or and it could be I didn't know what I was. It was a guess, and I didn't know, but now I reviewed it and I know the right answer. I know how to get it. That's what I'm doing. Is I'm just wanting to see that you've corrected that, and you'll get half those points back. Okay, and that's why I put those PDFs in there. I can look which questions you missed, give you half those points back, and that will update your score on the exam. I'm not so worried about due dates, but again, just try to keep on track with what we're doing going forward. We've got 6 more chapters to go through, another exam on those. But while you do it, work those in, and we're all good. Okay. So I'll stop the video here. We'll go into work session.